Alright guys, let's start lesson 1 of our new unit with a quick warm-up. So if I'm given a quadratic and I'm able to factor it, I can graph it using the zero product property. Okay, so I can see using the zero product property that the x-intercepts are going to be 3 and 1 because of course the way I find the x-intercepts is by setting y to 0 and solving. So it's very easy to see that the two x values that make this 0 are 3 and 1. How do I use that to help me graph? Well, I can plot my 2 points, my two x-intercepts, and then I will need the vertex. So in order to get the vertex, I can find xv, which is the midpoint of 3 and 1. So we see that xv equals 2. And this is also my axis of symmetry for the parabola. So in order to find the y value of my vertex, what I have to do is evaluate my function at the x value of the vertex. So in this case, I have to evaluate the function at 2. So once I know my vertex is 2, 2, I'm able to sketch this. And again, I could actually figure out the value of the y-intercept by setting x to 0. Why don't we do that? We might as well. I got it right. Okay, so, and then I could also see that this will be at -6. Amazing. Okay, so does y equals 2x squared plus 8x minus 6 have x-intercepts? Yes, it does. Does this make sense with the result from A? Yes, because using the zero product property, we could see that this equation here has 2 solutions, so it has 2 x-intercepts. So that's our warm-up, and I'm going to use that as a springboard to bring us into the quadratic formula, because as we'll see in the next 2 examples, which look really similar, we cannot always do what we just did in example 1. So let's try this. So if I want to factor this guy, I can see that I can't first factor out a -2. What I have to do is multiply a times c. So a times c in this case is -2, -18, and then I'm going to use the product sum to break up our middle term 8x. So I need to write down all the factors of 18. And normally what I would do is I would try to pick the pair that gets me 8x. But since no pair gets me 8, or I should say 8x, I cannot factor -2x squared plus 8x minus 9. So, okay, I also can't state the x-intercepts because I can't factor. So what do I do for part B? Well, does that mean I can't graph it? Not at all. We know how to graph this actually. First, we need to put it in vertex form, and the way we put it in vertex form is by completing the square. And we know that the way we graph this is by starting with our 5 important points. Okay, so does 2x, let's look at part C. Does negative 2x squared plus 8x minus 9 have any x-intercepts? Well, no. I can see that from the graph. Does this make sense with your result from A? Well, I noticed in part A that I couldn't actually factor this, and I couldn't state the x-intercepts. But I'm not really sure. I guess maybe it makes sense with my result from A. But I don't really feel good about that. Just because I can't factor something, I'm not sure if that necessarily means that my quadratic has no x-intercepts. So let's look at a third example where I think we can clarify this. Okay, so again, we're going to factor this guy. And again, we can see that I cannot break up my 8x into either of these two factors here. Okay, so I can't factor. Meaning I cannot use the zero product property to find the x-intercepts as I did in number 1. I also had this problem in question number 2. Let's graph it. Okay guys, so let's look at part C. Does the parabola have any x-intercepts? Well, we can see that definitely yes. There are x-intercepts of this graph. Does this make sense with your result from A? Well, again, maybe. I'm not sure. I'm not sure what we can say here. So all I know is that I can't use the zero product property to find x-intercepts. So essentially, what I wanted to do is summarize these 3 cases, and what we'll notice here is that in part, in question number 3, so this guy, it's very clear that we have x-intercepts, but they're very ugly. So let's copy our results to the next page, and we can summarize. Okay, so let's just take a moment now to summarize the 3 examples we just looked at. So number 1 was factorable. And we notice here we have 2 x-intercepts, and those intercepts are 1, 0, and 3, 0. We notice for number 2 that it was not factorable. We also notice that there were no x-intercepts. In the last one, this one was also not factorable. And we can see that there are 2 x-intercepts. But here's the thing, we don't know what they are. And if I take a closer look at these x-intercepts, we can see that actually they're really ugly values. So how on earth would I be able to find these numbers, okay, when I'm trying to factor this guy? Okay, so the answer is we don't do that. What we do is we use the quadratic formula. But before we get there, let's just summarize these facts about factorability and the number of x-intercepts. So what we can say with certainty is that this here is true. We know that if my function, if my quadratic is factorable, okay, then I know that my quadratic intersects the x-axis. This is like example number 1. So if something is factorable, it definitely has x-intercepts. Now, the following we've seen is false. If I try to flip this logic statement, if I try to flip it around and say that if ax squared plus bx plus c intersects the x-axis, then it's factorable. Well, that's not true, because we can see that in example number 3, okay, I have two x-intercepts, but it's not factorable. Okay, what we can say though is that if ax squared plus bx plus c, if my parabola intersects the x-axis, I should be able to find values of x that satisfy ax squared plus bx plus c equals 0. So y equals 0 means x-intercepts. Okay, so how do I do that? Okay, so let's summarize in this box. Sometimes, even when there are x-intercepts, it's not easy to factor a quadratic into factored form. We need a different method. What is that method? Well, if you've been paying attention, you will know that it is the quadratic formula, and we are going to derive that in our next page.